Number 5 should have been 1 to 116, or 1 over 116 like that. Number 6 should have been 36. Number 7 is 6. Number 8 is 55 over 4, or 13 3/4. Number 9 is 6, and number 10 is 7.
Wait, can you do number
10? Sure. All right, so 10 is our proportion. How do we solve proportions? Cross multiply. So I would get 8 times x minus 3 equals 2 times x plus 9. And then I have to distribute the 8 into both, 8x minus 24, and the 2 into both, 2x plus 18. And then subtract the 2. This becomes 6x minus 24 equals, cancels 18. Add the 24. 6x equals 42. Divide both sides by 6. And x is 7. Okay, just be careful. I would say biggest mistake made on stuff like that is forgetting to distribute to both. So a lot of you will make that mistake. Try not to forget to do that. Okay, 6 says the measure of 2 complementary angles are in the ratio of 2 to 3. What's the measure of the smaller angle? So these are like our little word problems, right? If it says complementary, what does complementary mean? 90. So 2x plus 3x equals 90. Because that was like on your quiz, it said supplementary. So you just got to pay attention to that word. Complementary is 90, supplementary is 180. It doesn't matter. It could be 3 angles, and then you would do this plus this equals. Yeah, it's just that this complementary is 90 instead of supplementary, which is 180, sorry. So this would be 5x equals 90. And then 90 divided by 5, which is 118. And then it says what's the measure of the smaller angle. So if I had 2 times x or 3 times x, which one's smaller? 2x. So I do 2 times 18, which is 36. Any other questions from this page before I move on? So that was all 7-1. Then came 7-2, right, which was your proportions of your similar polygons, not necessarily triangles, but any shaped polygon. So 11 was JEHN is similar to JKLP. Now those can be arranged if it matches still. So wherever the J is in the order of the letters in 1, it should be the same. Wherever the E is, the K should be in that same location. H should line up with L, and N should line up with P. If you look at the angles, that's probably the easiest way to do it, right? The 2 right angles would match up. The one with 1 arc would match up. The one with 2 arcs would match up. And then it said also give the similarity statement, which is this, and the scale factor, which should be 3 to 4.
That's when you do like 18 over 24.
Yep. So there was like 24 would have gone, well, that's the actual, this is 18 would have gone to 24. 36 would have gone to 36 plus 12. And those are your completed ratios. And then you would simplify from there.
What's another way to write 3/4?
Say again?
Is there another way to write 3/4?
You could write 3 over 4 like that. Is that what you mean? Yeah. Okay, and then 12 is triangle PQR is similar to triangle XYZ. Again, the order can be rotated. Like I could have said QRP if I said YZX. I could have said RPQ if I said ZXY. Any of those orders are okay. And the scale factor here is 3 to 2. So be careful and make sure you're paying attention to directions, right? It said, write the similarity statement. That's what's similar to what. And then give the scale factor. That's a 2-part question. So on your test, you could get like one that has a couple of things that you're having to include, and you want to make sure you don't miss any of that stuff. Phyllis.
So you don't have to put all 3 or just the options?
Just one of, yeah, just one of those 3. Any of those 3 worked. Okay, then 13 is 120 feet. 14 is 45 feet. 15 is 2 to 1 for each side length. So it's yes, and it's side, side, side similarity.
Can you do that?
Sure. So I would look at the two. First of all, remember there's 3 ways to prove they're similar, right? Side, angle, side, similarity. Side, 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 similarity. And angle, angle, similarity. So the fact that you know nothing about the angles means the only way these could be similar is if all 3 sides paired up. So then I look for the one on the left. Let's say I go in order of biggest to smallest. Largest side is 10. Go to the second triangle, largest side is 5. Triangle on the left, middle side is 8. Go to the one on the right, middle side is 4. Back to the one on the left, smallest side is 6. To the one on the right, smallest side is 3. If these all reduce to be the same thing, which they do, they're all 2 to 1, then I would say these triangles are similar. And the reason is side, side, side. If they do not all simplify to the same thing, then these triangles are not similar. These are similar because of angle, angle, similarity, okay? And these come from your parallel lines. So if you remember parallel lines with a transversal, this goes back to like first semester, right? You have something called corresponding angles, which tell you that this angle is congruent to this angle, and this angle is congruent to this angle. You also share T in both triangles. So you technically have all 3 angles there. You only need 2. You know nothing about the side lengths there, so that's your hint to test your angles. Any questions on those before I move on? Okay, so 13 says the length of a rectangular playground in a scale drawing is 12 inches. If the scale is 1 inch to 10 feet, what's the actual length? So they're giving you a scale of 1 inch to 10 feet. For every 1 inch, it's 10 feet, right? Inches, feet. Then it says that the drawing is 12 inches. So that's going to go where the inches are. And the feet, which is the thing you're trying to find, is going to be your variable. So you can either like multiply straight across, or you can cross multiply. 1 times x is x, and 10 times 12 is 120. So you just got to figure out your ratio. There it went inches to feet. So you want to continue in that pattern, inches to feet. Number 14 says a 3-foot vertical post casts a 24-inch shadow. So now I've got the post over its shadow would be 3 to 24. At the same time, a pine tree casts a 30-foot shadow. So now I'm doing the tree to its shadow. And the pine tree is is what we don't know. And so this is 30 feet. This is inches. So the first thing you have to do is convert those feet to inches, right? So this would be times 12. So it would be 3 to 24 would equal x to 360. Then it could be 1/8. So 8x equals 360. And 8 goes into both of those. And it'd be 45. I actually think that's trickier than any question on your test because I didn't do different units. Okay. As long as you can figure out how to set up the ratio and then set it like to the proportion. Better example would be like 13 over 14. 14 is a little trickier just because of the inches to the feet. Okay. Okay, then came, then came 7-4, geometric mean, and then the 2 proportions that we need. So number 17 is 12. Number 18 is 2 root 15. Number 19, x, is 6 root 2, and y is 6 root 6. Yes. I'll go back to it, okay? 20 is the square root of 35. 21, x equals 2 root 21. Y equals 4 root 3. And 22, x is 12. And y is 4 root 5. Okay, so number 9 has both. This is a good one to review because it has both of them, right? It's got, okay, we'll see how many I can get through, but yeah. So from this section, remember you had 2 proportions. Once you had a altitude drawn into a right triangle. One was segment 1 over altitude equals altitude over segment 2. And the other is the hypotenuse of the big triangle over the leg equals the leg over the segment of the hypotenuse adjacent to the leg. So if I look at 19 and I want to solve for x, what kind of segment is x? Is it a hypotenuse? Is it a leg? Is it an altitude? On the big triangle, that would be what? The altitude, yes? The one that's inside the big triangle is the altitude. So I know I have to use this proportion. So I would do segment 1, could be 12 or could be 6, doesn't matter which one, over x equals, you repeat the altitude, over the other segment. So I could have switched the 12 and the 6, it would have been fine. From here, I cross multiply. So I'd get 12 times 6 equals x times x, or 12 times 6 equals x squared. Now, I can multiply those out, but I'm going to end up square rooting them, like I'm basically finding the geometric mean. So I can save myself the trouble of multiplying it because I'm just going to break it down again. So I would say that x equals the square root of 12 times 6. So then 12 breaks down into 2 and 6. This breaks down even further if you don't see it yet. 2 and 3, and this is 2 and 3. So now I'm going to look at all those numbers, all those prime numbers where we stopped. And I'm going to say, are there any that repeat? What's the answer? Yes. What repeats? These two mean I'm going to bring out 1, 2. I have another 2, but it doesn't have a match, so that's going to stay underneath the radical. And then I have 2 3s, so that 3 comes to the outside. I multiply those together, and I get 6 root 2. That's your x. So 2 skills here. 1 is setting up the proportion and cross multiplying. 2 is the square roots, okay? Then I want to solve for y. Y in this big triangle is what? Hypotenuse, altitude, or leg? It's a leg, right? So I'm going to use the second proportion, which says hypotenuse. And when you say hypotenuse, you're talking about the hypotenuse of the big triangle. So I have to add the 12 and the 6 to get that. So I would do 18 over the leg, which is y, equals the leg, which is y, over the segment of the hypotenuse adjacent to the leg. The hypotenuse is divided into 2 segments, this one and this one. Which one is adjacent to y? 12, right? Adjacent means closest to or next to, right? So this is the one that's closest to the y. That's why I picked 12. Now, cross multiply. 18 times 12 equals y squared. And y equals the square root of 18 times 12. I'm going to tell you right now, these numbers could be big tomorrow. Don't multiply them out to just have to break them down again. Take them as they are and break them down. So this would be 2 and 9, which is 3 and 3. 2 and 6, which is 2 and 3. Then I get a pair of 3s, a pair of 2s, and then a single 2 and a single 3 that's going to end up underneath. And I get 6 root 6. $20 only has x, right? I only have to solve for 1. But is x a leg, a segment, a hypotenuse, or what am I missing? Or an altitude? It's an altitude, so I'm going to use the top one. I'm going to say segment 1, which can be 5 or 7, doesn't matter, over the altitude, which is x, equals the altitude, which is x, over segment 2 now has to be 7. But again, 5 and 7 could be switched. I get 5 times 7 equals x squared, so x equals the square root of 5 times 7. Can either of those break down? No, they're both prime. Nothing's going to repeat, which means x is equal to the square root of 35.
So for the problem, you just look at the 2
It's going to be one or the other. You just got to figure out, is what you're looking for an altitude? Is it a leg? Is it the hypotenuse? And then based on that, you'll know which one to pick. Yep. These two. So S1 stands for segment 1 over altitude equals altitude over segment 2. And then hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. So I'll do one more of those because that's the other one. Let's just solve for x, and then we can go back and do y if we have the time. But let's just solve for x, because x in that big triangle, x is what? A hypotenuse, a leg, or an altitude?
Leg.
It's a leg. So I'm going to use this second one, which says hypotenuse over leg equals the leg over the segment of the hypotenuse adjacent to the leg. So what's the hypotenuse of the big triangle? 14. The leg is what we don't know. That's my x. That's going to repeat. What's the segment of the hypotenuse adjacent to the leg? I heard one right, one wrong. So why is it not 8? Is that next to x?
No.
This is the segment next to x, right? How do I know that length? Almost there. Subtract the 8 from the 14, right? So this would be 6. Does that make sense?
Yes.
Okay, so then this is 6. Now cross multiply 14 times 6 equals x squared. X equals the square root of 14 times 6. So 14 breaks down into 2 and 7, and 6 is 2 and 3. And then I have 2 2s, a 7 that has no match, and a 3 that has no match. So that becomes 2 root 21. Because there's 2 2s, right? Like 14 broke down to 2 and 7, and then 6 breaks down to 2 and 3. So there's 2 2s. One of those goes to the outside, but then there's a 7 and 3 without a match. So I'm telling you right now that there's 2 parts to this, right? The setup and then the actual finish of it. If you leave this whole question blank, you lose all those points. But if you can at least give me the setup and then maybe the errors in your square roots, okay? At least I can give you partial credit. Do not leave these blank. At least do the setup, okay? And then try the square roots. If the square roots where you get hung up, at least I can give you points for the setup, okay? But don't get frustrated and leave them blank. That's like the worst thing you could do, okay? All right, I'm going to do 22 because it's a little different. And I'm just going to do x. X is what segment in that triangle? Hypotenuse, leg, or altitude? Y would be altitude, right? The one inside the altitude. That's a leg, okay? How do I know that's a leg and not the hypotenuse? So how do I know that's not the hypotenuse of the big triangle? This is the hypotenuse of the big triangle. How do I know that? It's opposite the right angle, right? I don't know if that's, it looks like it's the longest, but you don't know it's the longest because you don't know what the other side lengths are, right? But I do know it's opposite the right angle, which makes it the longest. Does that make sense? So 18 is my hypotenuse, yes? So because I'm looking for a leg, we said x was a leg, I'm using hypotenuse, which is 18, over leg equals leg over segment of the hypotenuse adjacent to that leg. So which of those segments is next to x? 8. And then I cross multiply 18 times 8 equals x squared. X would equal the square root of 18 times 8. And then I'm going to break that down. So 18 can be 2 and 9, 3 and 3, 8, 2 and 4, 2 and 2. So now there is 1, 2 2s. A 2 is going to go to the outside. 2 3s. A 3 is going to go to the outside. Another pair of 2s, which means another 2 goes to the outside. There's nothing left by itself, which means there's no square root in this answer. I would just do 2 times 3, which is 6, times 2, which is 12. Marcella.
How'd you get the square root of 18 times?
So are you good on this step?
Yeah.
Yeah. So I need to get rid of this squared. And in order to get rid of that, I have to square root both sides of the equation. So the square and the square root cancels and I just get x. But then this stays underneath that square root. And you can, like I said before, I could multiply that out and I would get 144 squared for 144 is 12, right? But I'm going to eventually have to break these down anyways, and they're not all perfect squares. So make it as easy as you possibly can. If I got something like 25 and 64, I definitely don't want to multiply those out to just break them down again. So keep them broken down and then break them down even further so that you can simplify it. Questions on any of the stuff on this review? Yeah.
You did 2 times
2 times 3, because this 2, right? So I did, these 2 were one pair. These 2 were a second pair. These 3 were the third. And then there's nothing left underneath to go underneath the square root. So then I take everything I brought outside and you multiply them together. If you bring outside more than one number, those get multiplied together. If you leave under the square root more than one number, those get multiplied together. Okay? Questions?